Hi there, this is Kenneth Corrigan again, and today I will be presenting Representing Knowledge from Chapter 16, Section 7. Get ready. So for just a quick introduction into the area of representing knowledge, representing knowledge and the links between pieces of knowledge is important and vital for many intelligence systems. Representing knowledge is also referred to as knowledge recognition, and then abbreviated to KR. There are various areas that KR can be applied, but the easiest to learn from, most common, and ultimately most complex is language recognition. And I will use the artificial intelligence language recognition in the slides to come. Nodes and weights. Nodes enable the representation of knowledge. Each of the nodes in this picture are the circles with words within them, such as fruit, moon, space, white, blue, sky, stars. Each of the nodes are connected by links, and each of the links have a weight. Now, the links we see are the lines with a number with them. So, the link between the sunset and orange is 9, and between sky and sunset is 3. This weight specifies the strength or importance between the two ideas. And for example, the relationship between sky and cloud carries a strength of 9, but just a strength of 1 is carried between the moon and the stars, and one would expect that. Just a strength of 1 is carried between the cloud and the moon and the cloud and the stars, and one would expect that. I think naturally we would associate the sky with clouds more than the sky with the moon or the sky with stars. So training comes into play when determining the nodes and their strength. It's because the weight of each relationship is determined by training. In this case, training could be done by asking people for the words they think when they hear the words sky or sunset or fruit. The more commonly another word is mentioned in association with one of these keywords, the greater the strength. This method is advantageous because incorrect training is unlikely. The most common associations will inevitably rise in importance, and the less common associations will fall. I chose to use a comic here that uses word association to make a joke. So. Next, for knowledge representation. Knowledge representation, such as this, can provide answers to questions in natural language. When considering the question, what color is the sky? Natural language processes can be used. Now, this doesn't seem like a complicated question, but the process used to obtain the answer can be a little tricky. So, the important words in this question are first established, and they are color and sky. Some strong associations would make no sense, such as saying the sky is moon or the sky is sunset, or even the most strongly associated word, the sky is clouds. Now, the strong association does make sense initially, but in context of the question it does not, and a human would recognize that. Now, although the words associated with color are orange, blue, and white, of these three, blue is the most strongly associated with sky, thus generating the answer, the sky is blue. So it took out the keywords, which were sky and blue, or which were sky and color, and it examined the associations between sky and the other words, and then with the other keyword, it found the association with the other keyword, which is color. It found the associations, which were orange, blue, and white, and saw that blue was the most strongly associated with sky, and thus generated an answer. The sky is blue. Now, finally, simple versus complex. This example with natural language is very simple, but in reality, this same technique can be used to answer very complex questions, just with more information necessary. And with more information necessary, it requires more training and more time, and just overall is much harder. And these are my sources. Very well done.